Hello everyone, my name is Jasmin Spencer and I have chosen to do my sports task breakdown on track and field. So before I get into the actual breakdown of the functional components of the task, I want to just give a brief summary of exactly what track and field actually is. So track and field, or athletics, is, as it is known in many countries, is the name given to contestants, male or female, and it involves running. So the great thing about track and field is that it's no longer limited to just those with able bodies. These events are open to males and female athletes in all disability groups of all ages. And throughout the years, with the advancement of technology and also the dedication of the athletes within this sport, they have made once unimaginable challenges become actual realities. I also wanted to hone in on those that participate in the wheelchair track and field. And as you can see, the young lady that is in the photo provided, she is actually a wheelchair track and field star. So let's get into the actual breakdown of the functional components that tie into wheelchair track and field. As you can see, the contestant here, he has trunk flexion. He also has slight shoulder abduction in order to have his hand placement on the ring of the tire. We have shoulder hyperextension, as you can see. We then have elbow flexion, elbow extension, and wrist extension in order to push and propel the ring on the tire. The question is asked, are the movements against gravity, gravity dependent, or gravity eliminated? So the trunk flexion would be gravity assisted because gravity is pulling the body down. The slight shoulder abduction would be against gravity because of course gravity will want to pull that arm back down into a neutral position. Shoulder hyperextension is against gravity also. Gravity would want to pull that arm back down into just extended position. Elbow flexion is against gravity. Gravity will want to pull that elbow back into a extended position. Elbow extension is gravity assisted because that is the neutral position and it's working with gravity. Wrist extension is also against gravity because gravity will want to put that wrist back into a neutral position, which is more of a flexed, slightly flexed wrist. So I placed some arrows with a picture so that you can see the location of the actual muscles. The rectus abdominis is responsible for trunk flexion, and that arrow is below the face, near the stomach area. We then have the posterior deltoid and latissimus dorsi, which is responsible for hyperextension of the shoulder. We then have the brachioradialis, which is responsible for elbow flexion. As you can see, the elbow is in a flex position. We then have the wrist extensors, the extensor carpi radialis longus, brevis, and the extensor carpi ulnaris, which is responsible for wrist extension, and there is an arrow pointing to the wrist for the location of those muscles. Those muscles will be on the posterior side of the hand. Two more muscles that are primary movers involved in the movement of the task would be the supraspinatus and the triceps. You could not really see them in the other slide with the picture provided, which is why I provided another picture so that you can see the actual movement. So the supraspinatus is responsible for abduction. Of course, the arm needs to be slightly abducted in order to place the hands on the ring of the tire, as you can see, and the triceps are involved in elbow extension. So I'll provide an actual figure of the actual type of contractions there are, which include concentric contraction, which is the muscle contracting, but the muscle is shortening. We then have isometric contraction, There is no change in the muscle length, but the muscle is still contracting. We then have eccentric contraction, which is the muscle contracting, but the muscle is lengthening. On the next slide that we're going to move on to, it will show actual pictures of the different muscles and the actual contractions that are occurring within those muscles. These are the actual visual of the different muscles that are aiding in the functional components of the task. So the first picture here, we're going to go from left to right. We have the supraspinatus, and that muscle is doing a concentric contraction because once the humerus moves up for slight abduction, that muscle is actually shortening. Then we have the rectus abdominis muscle, which is located in the trunk area, which provides trunk flexion. As the trunk goes down into a flexed position, it is shortening, which is why it is a concentric contraction. We then have the wrist extensors. All three of them are listed. That movement, once the wrist is extended, the muscles are shortening, which is why it is a concentric contraction also. We then move down to the second row, and those are the triceps, which provide the elbow extension. And within this contraction, it is also concentric because the triceps are shortening also. We then have the brachioradialis, which is located on the forearm and is responsible for that elbow flexion. And as the elbow flexes, that muscle also shortens, and that is concentric contraction. We then move on to the posterior deltoid, which is the back part of the deltoid. And we also have the latissimus dorsi, which is on the back side of the trunk. And that is responsible for that hyperextension. And once that movement occurs, that contraction is concentric also because those muscles will then be shortened. So we have some slight force couple utilization going on with a slight abduction. We have upper rotation. And then once the shoulder is transitioning from that hyperextension back to extension, you have some downward rotation, but not much. But there is some force couples going on, but it's not being fully utilized as it would in a full abduction or a full flexion to a extended position. Strengthening exercises are very vital when it comes to targeting certain muscles so that you can get that optimal performance during the task at hand. I chose to strengthen the wrist extensors, which are responsible for propelling the actual wheelchair during the track and field activity. I then chose to strengthen the rectus abdominis muscles, which are responsible for that trunk flexion. I also chose to strengthen the brachioradialis, which is also responsible for propelling the wheelchair forward also. With the wrist extensor exercises in the picture provided, you can see the young lady has her wrist in a neutral position, and you will then bring your wrist into a extended position, and you can do that 10 times, 3 sets. With the sit-ups, you can do those 10 times, 3 sets also. But when we get down to the brachioradialis strengthening exercise, you don't want to confuse that with bicep curls because they are not bicep curls. And I say that to say you want to make sure that your hand placement is correct. With doing the brachioradialis curls, you want to make sure that your thumbs are pointed up so that you know in fact that you are targeting the brachioradialis and not the other two elbow flexion muscles. So again, thank you for tuning in to my presentation.